Good evening, students. I would invite Arun sir to start the session.
Thank you, ma'am. Give me a minute, students. I'll just connect the video.
Good evening, sir.
Yeah, good evening, Vignesh.
Good evening, sir.
Good evening, good evening, Gayatri. Okay, so again, we have got a class separately for IIT. We'll start the syllabus at 7:30. You don't have a maths class today. So right now, we have got only MPC students with us. So any specific doubt, we'll do that. Or if you want me to carry on with integration, I'll do that. Because 7:30 we'll start go ahead with the syllabus, circular motion, because that time Neet students will join us.
Sir, you mean you will tell the concept of integration, sir?
All right, I'll tell you integration. So in integration, what we usually do in physics is we sum up elements. We divide the whole mass, charge, or length, or any object into infinitesimal pieces, infinite number of infinitesimal pieces, and we sum them up using integration. And the kind of formula we use in physics is very limited. Hardly 3 or 4 formulae we have got. Integral x dx is one, integral sin x is one, integral cos x is one, integral f dash x mod x is log mod fx is one. So all that we'll consider, that's okay. But right now, let's say I have to find out what a rectangular square plate, not rectangular, I got a square plate. Here, this plate, it's sigma, surface mass density. Surface mass density is nothing but mass per unit area. So sigma is varying as sigma of x is equal to sigma naught x by L. As x varies from this corner to this corner, this edge to this edge. It's a square of length L. Required to find the mass of the square plate. Last time we have done for a rope. That's why I'm not doing for the rope now. These such configurations are very much required for center of mass, rotational motion, fluids, and then you have got like many other topics, which are which. Sorry,
సార్ అది ఈక్వేషన్ ఎట్లా వచ్చింది సార్
ఇది నేను
ఈక్వేషన్ ఎట్లా వచ్చింది
ఈ సిగ్మా నేను ఇచ్చాను
yes
given in the question. That
okay
could be that could be anything. Sigma naught into e power minus x by L or some function of x. So this thickness is varying from here to here. Density is varying from here to here. ఇక్కడ less dense ఉంది, ఇక్కడ ఎక్కువ వెళ్తుంటే ఎక్కువ డెన్స్ ఉంది. If my function is sigma into x by L, as x is increasing, my density is increasing. If my function is this one, my density over here is more, density over here is less, because e power minus 1 by x minus x only, which is dropping exponential, a decreasing exponential. When x is equal to 0, it is sigma naught. When x is equal to L, it is sigma naught by E. All right. Now,
yes
now look at this. For rope, what did we do? at a distance x, I've considered an element dx whose mass was dm. Now dx was so small that lambda was assumed to be constant in this length dx. So dm was lambda into dx. Linear mass density into length is my mass. I'll do the same thing here.
So lambda అంటే సార్ అందులో lambda.
Okay, there are three kinds of densities: lambda, sigma, and rho. Lambda is linear mass density, sigma is surface mass density, rho is volume mass density. Mass per unit length, mass per unit area, mass per unit volume.
Okay, sir.
Okay.
Sir,
Yes, Vignesh.
spotlight ఆఫ్ చేస్తారా సార్?
Huh?
స్పాట్లైట్ ఆఫ్ చేస్తారా?
Oh, all right, all right. Just a second. Okay. Now look at this. Lambda is linear mass density. So whenever you're considering a thin length, thin rod, you talk of lambda. When you consider a thin sheet, you talk of sigma. When you consider a volume, mass or volume, 3D space, then you talk of rho, volume mass density. A thin rod, linear mass density. A thin sheet, surface mass density. 3D space volume, volume mass density. All right. So lambda రాయగానే మీరు అర్థం చేసుకోవాలి that I'm talking about a linear rod, thin rod. All right. Now, what I'll do over here is at a distance x, I'll consider a thin strip of width dx. Now, sigma dx is so small that sigma is considered to be constant in this area. What is the area of this strip now? Length is L, thickness is dx. Area is L naught dx. Area is L naught into dx. Sigma of x into area will give me mass, dm. If I integrate this, I'll get m, total mass. But I integrate from where to? From 0 to L naught.
So,
all I have to do is plug in sigma of x, variation Li icharu question, I'll plug it in, I'll integrate it. Let
Sure.
us say variation is sigma naught into x by L. So sigma naught into x by L into L naught dx. Integrating it from 0 to L naught. L naught gets cancelled out, sigma naught comes out, integral x dx. 0 to L naught.
సార్
Yeah,
మీరు సిగ్మా ఆఫ్ ఎక్స్ ఎందుకు తీసుకున్నా చెప్పండి.
sigma of x is surface mass density, variation of surface mass density on the sheet, of the sheet. But sigma of x ఇచ్చారు question లో. All right, that could be sigma into x by L, e power minus x by L, or any other function, x square, ln x. It could be some function of x. But in general, it's sigma x, sigma of x. That function into area will give me mass of that area, mass of that strip considered. See, my variation is with respect to x. So ila em variation ledu. So sigma is constant on this area, on this strip. Vertically move అయితే my sigma is constant. It's only varying with respect to x horizontally. So with respect to vertical distance, it's constant. So sigma on this strip is constant. If I consider dx to be so small that sigma is not varying in the strip, then sigma on this is constant. Sigma into area of the strip will give me mass of the strip. What is sigma there? Sigma of x. Whatever the value there, x is, sigma of x is my sigma value at that position x. Sigma of x into area will give me mass. Integrating this mass from 0 to L will give me total mass. All right. Is it okay, Vignesh?
Yes, sir.
Can you repeat once again?
See, all I'm doing is sigma of x ఉంది కదా. At x, what is the value of sigma? Sigma of x. That's the function. ఈ strip లో my sigma is remaining constant because dx is so small that I can treat sigma to be constant. Sigma constant ఉన్నప్పుడు what is my lambda constant ఉన్నప్పుడు నా మాస్ ఏముండే lambda into linear mass density into length. Linear into length is my mass. Areal mass density into area is my mass. So sigma of x, surface mass density into area L naught dx is my mass, the element which is dm. But if I want complete mass, I integrate this from 0 to L. Now this will give me total mass. That's what I'm doing. Sigma of x could be anything. Sigma constant ఉండొచ్చు, variable ఉండొచ్చు. It could vary with linearly with x, exponentially with x, quadratically with x, or parabolically with x, anything. But sigma of x is general function. అది sigma not constant ఉందనుకోండి. For example, it's constant. So what do you get? When area is constant, surface mass density is constant, what is the mass of this one? Surface mass density into area, right? Sigma naught into L naught square is my mass. If linear mass density is constant, lambda naught, if length is L naught, what is the mass of that one? Lambda naught into L naught. So when I integrate this with, when sigma of x is constant, let's say, it is sigma naught. What should I get? I should get sigma naught into L naught square. Let's see whether we are getting it or not. Sigma naught L naught into integral 1 dx from 0 to L naught. What is integral 1 dx?
Sir, x, sir.
X, right. X. So sigma naught L naught into x under limit 0 to L, which becomes sigma naught into L naught square. That's what we are getting here. So area surface mass density into all right. So now let us say sigma is varying with x as sigma into x by L. I have to find out a mass of this whole plate. So what is the mass of the whole plate? Sigma of x into area of the strip L dx is my dm. I integrate this under proper limits 0 to L naught because my mass is going from 0 to L naught. I want the total mass. If I want only half the plate, then 0 to L naught by 2 or L naught by 2 to L naught, only depending on what is asked. So I'll substitute sigma of x as sigma into x by L. Sigma naught into x by L into L dx, integrating it from 0 to L naught.
Sir, can you repeat that again?
Okay. See, sigma of x is, this is my dm. Integral dm is my m. Summing up dm gives me m. Summing up dm, very small elements, if I sum up, I'll get total mass m. But what is dm? Areal mass density into area. Surface mass density into area. Surface mass density is sigma x at that position into area is L dx. Why is it L dx? Dx is the width, L naught is the length. Length of the strip is L naught, width of the strip is dx. So area of the strip is L naught dx. Now sigma of x is given as sigma naught into x by L. So L naught gets cancelled out. I'll have sigma naught comes out. Integral x dx. What is integral x dx?
Sir, x square by 2.
Right. So sigma naught into x square by 2 under limit 0 to L, which is sigma naught into L square by. So that's the mass of the whole strip.
సార్ ప్లేట్ మొత్తం ఏరియా సిగ్మా నాట్ ఎల్ నాట్ స్క్వేర్ బై 2 మొత్తం షీట్ లేకపోతే ఆ స్ట్రిప్ ఓన్లీయా?
ఈ స్ట్రిప్ ది ఇంత ఉంది. ఓన్లీ స్ట్రిప్ ఇది ఉంది. మాస్ ఆఫ్ ద స్ట్రిప్ ఇస్ సిగ్మా నాట్ ఎక్స్ బై ఎల్ ఇంటూ ఎల్ నాట్ డిఎక్స్. ఎల్ నాట్ డిఎక్స్ ఆ స్ట్రిప్ ది ఇంత ఉండదు కదా. స్ట్రిప్ ది డిపెండ్స్ ఆన్ డిఎక్స్. డిఎక్స్ ఇంత ఉంది, విడ్త్ ఎంత ఉంది, ఏరియా ఎంత ఉంది, ఎల్ నాట్ డిఎక్స్ ఉంది. ఏరియా ఇంటూ సిగ్మా ఎల్ కి మాస్ ఆఫ్ దట్ స్ట్రిప్. దిస్ ఇస్ మాస్ ఆఫ్ ద స్ట్రిప్. If I integrate, if I sum up, integrate means sum up all the strips. అన్ని స్ట్రిప్స్ నేను సమ్ అప్ చేస్తే I get total mass, which is sigma naught L square by 2. So this is the mass of the whole strip. Oh, sorry, whole rectangle, whole square. And this is the mass of the strip. ఒక స్ట్రిప్ తీసుకొని దానికి మాస్ రాస్తాను. I'll integrate it. I'll sum it up. When I sum up, I'll get the total mass. Okay, let us do some 5 to 6 problems only, then you will understand. This is L naught. This is 2 L naught. Or let's say this is L1, L2. L1, L2. It's a rectangle. All right. Now, my variation of density is with sigma of x is equal to, is varying with x from here. X from the bottom edge. ఇక్కడ నుంచి x vary అయితే my sigma is varying. How is it varying? Sigma naught into x by L. Sigma naught into x by L2. Or let's say sigma naught x into vary అవుతుంది. All right, some constant sigma naught x into x. Sigma naught into x. But for simplicity, let's make it L2.
సో
So this is the variation of sigma. Yes.
L2 తీసుకోవడానికి రీజన్ అది ఆ సర్ఫేస్ లో మూవ్ ఆ డైరెక్షన్ లో మూవ్ అవుతుందన్నా సార్?
ఇక్కడ ఏం మూవ్ కావట్లేదు. నేను ఇక్కడ నుంచి నేను మూవ్ అయితే మై డెన్సిటీ ఇస్ గోయింగ్ ఆన్ చేంజింగ్.
యా సార్,
let us
అదే
see.
ఆ ఎల్ నాట్ సర్ఫేస్ మీద మూవ్ అవుతున్నాం కాబట్టి కింద ఎల్ నాట్ తీసుకున్నాను అంటే సార్.
No, this given function I can write it as k naught x. All right, sigma is varying as k naught x. Some constant into x, some linear function of x. It could be anything. It could be constant, it could be quadratic, it could be linear, parabolic, exponential, anything. That depends on the construction of this sheet. We are not bothered about that. We are bothered with the function. How is the function varying? Function ఎలా vary అవుతుంది? Sigma naught is equal to k into x, or k naught is c into x, a into x, k into x, some linear function of x. And let's say this is L1, this is L2. I have to find out the total mass of the strip. So I'll have L1 k into L2 answer లో ఉంటాయి. Because my total, all the constants are L1, L2 and k naught. So I'll have answer in terms of k naught, L1 and L2. Let's see how to find out. At a distance of x, I consider a thin strip of width dx. All right, look at the strategy. Same thing you have to repeat for 100 times, then that will seep into your brain. At a distance of x, I consider a thin strip of width dx. Length L1. What's the area of the strip? What is the area of the strip?
dx into L naught.
L1. L1 into dx.
Yes,
sir.
L1.
This area into sigma of x will give me dm, mass of that strip.
How, sir? dm is equal to sigma of x into L1 dx.
Sigma is equal to m by a. Alright. Mass per unit area is sigma. So m is equal to sigma into a. Alright. Mass is equal to sigma is mass per unit area. Definition of sigma nt mass per unit area. Definition of lambda nt mass per unit length. Definition of rho nt mass per unit volume. Mass per unit area ఉన్నప్పుడు mass is equal to sigma into area.
Yes, sir.
Yes,
So
sir.
mass is equal to sigma into area. Sigma is sigma of x into area. Area is L1 dx. Ante.
Yes, sir.
Is it okay, Bhavna?
हाँ, sir.
Okay. Now I integrate this. So I'll get total mass m. ఇక్కడ నుంచి ఇంటిగ్రేట్ చేయాలి ఇప్పుడు ఇంటిగ్రేషన్ లిమిట్స్ చెప్పండి నాకు I should integrate the whole sheet. Sum up all the elements. Sum up all the infinitesimal elements. Infinitesimal elements ఎక్కడి నుంచి వెళ్తున్నాయి
From
0 నుంచి
0
0
to
నుంచి
L2.
0 to L naught, sir.
right 0 to L2. That's it. Now let's substitute sigma of x as k naught x. K naught x L1 dx integrating it from 0 to L2, which is equal to k naught L1 comes out x dx integrating from 0 to L2. What is integral x dx?
X square by
Under limit 0 to L2, which becomes k naught L1 L2 square by.
L2.
Now that is the mass of the whole strip, whole sheet.
Yes, sir.
All right. Now about a cylinder. Length of the cylinder is L naught. Radius of the cylinder is R naught. Okay, it's a right circular cylinder. Now required to find, let's say volume కనుక్కోవాలనుకుందాం. Volume of the cylinder. What is volume of the cylinder? Pi R naught square into L naught.
That's
Nothing but
correct, sir.
area of this plane into length. అంతే కదా?
Length. Yes.
Right. So now what I do, now let's say it is rho naught is density of rho of x. Rho naught is varying as rho of x from this end. As x is increasing, my rho of x is varying. Alright, that could vary as some constant into x. So rho of x is varying as constant into x. I have to find the mass of the whole cylinder. Again, what I do, I'll select a strip such that at a distance x, I consider a thin disk. I'll consider a thin disk. At a distance x, ఇలా సెక్షన్ చేస్తే ఒక dx ఎలిమెంట్ ది dx width ది ఒక థిన్ డిస్క్ తీసుకుంటారు. ఆ డిస్క్ లో definition of density, volume density is m by v. So m is equal to rho into v.
Sir, అది హోల్ సిలిండరా?
Solid cylinder. This is a solid cylinder.
ఓకే సార్.
Alright, that's why I'm getting a disk. లోపల కూడా mass ఉంది. So mass is equal to rho into density, rho into volume. What is rho? Rho of x into volume enta ippudu volume of the element enta dv
Pi r square which means pi r L naught, sir.
pi r square
L naught
dx,
dx.
right? Area into width, pi r square dx. Now I integrate this from where to where?
From 0 to L naught, sir.
0 to L naught, right? Because my x is my variable here. X ఎక్కడి నుంచి వెళ్తుంది? X 0 నుంచి స్టార్ట్ అయ్యి L naught వరకు వెళ్తుంది. So if I want the total mass, I'll integrate from 0 to L naught. If I just want half the cylinder, I'll integrate from 0 to L by 2. One third the cylinder, 0 to L by 3. I just want the last part of the cylinder, last half part, L by 2 to L. అలా integrate చేస్తాను. Depending on what is required. But I want the total mass. So for that, I'll integrate from 0 to L. Rho of x into volume of dv. I'll get dm. Summing up all the dm's will give me total mass m. So let's say it is C naught x. C naught x pi r naught square dx. Integrating it from 0 to L naught. Now that becomes integrate. Tell me what's the answer?
C naught L naught square by 2 into pi r naught square.
Correct. Now that's the total mass of this cylinder.
So I don't get it.
Sorry?
ఇంటిగ్రేషన్ ఎలా చేస్తారో అర్థం కాదు.
Integration, huh? Vignesh, integration.
Yes, sir.
All right. See, C naught is constant, pi r square is constant, which comes out. Integral x dx. What is integral x dx?
X square by 2.
That's it. I remove this. I write it as x square by 2 under limit 0 to L. I substitute the upper limit. C naught L naught square pi r naught square. Lower limit is 0. That's it. Shall we complicate the problem a bit? Shall we do a little complicated problem?
Yes, sir.
Got an equilateral triangle. All right. So 60, 60 and 60 equilateral shape and the. So let the length be L naught. Now, this, let us say there are two cases. In the first case, my sigma is constant, which is sigma naught. In the second case, it is varying as C naught into x. All right. రెండిట్లో ఇంటిగ్రేట్ చేసి let us find out the total mass of this sheet, triangular sheet. And this x is varying from here. That means as x is increasing, I have got vertical strips of constant density. Vertical strips of constant density. If I find out mass of each strip, sum up all the strips. Summing up means integration mathematically. Physically summing up means integrating mathematically. If I sum up all the strips, I'll get mass of the whole triangular plate. So let's write down what's the area of the strip. If this is x, how much is this, students?
Trapezium, sir. Sir, it will become a trapezium. The
Yeah, yeah.
strip.
Yeah, strip is, yeah, but I'll consider it to be so small that I'll treat it as a rectangle.
L naught by 2.
No, this is not L naught by 2. See, the x equal is L naught by 2. But see, it is within this L naught. Less than L naught. Kada? Lopale
Yes.
undi kada? Triangle కంటే లోపలే ఉంది.
Sir, L naught into dx. If we consider
Ah,
that as
right.
dx.
Yeah, this
Then
is dx. Correct. This is dx. But this is not L naught. ఇది ఎంత ఉంటుంది?
not by 2, sir.
No. ఇది L naught
Huh?
ఉంది. టోటల్ L naught ఉంది. ఇది L naught
Yes.
కంటే చిన్నగా ఉంది కదా? లోపలే ఉంది కదా?
Yes, sir.
So let us say this is y. Y by x is equal to tan theta. Tan 30. Y is equal to x tan 30. X by root 3. So x by root 3 ఉంటుంది ఇది. సో టోటల్ ఎంత ఉంటుంది? 2x by root 3 ఉంటుంది.
Yes, sir.
Is it okay? You understood the length is 2x by root 3?
Yes,
Yes, sir.
Ah. Now, look at this. If this density is constant, density into area will give me mass. What's the area of an equilateral triangle?
Root 3 by 4 side square, sir.
నాకు మాస్ ఇంటిగ్రేట్ చేస్తే కూడా ఇది రావాలి. సో డైరెక్ట్ ఫార్ములా, బట్ ఈ ఫార్ములా ఎక్కడి నుంచి వచ్చింది? ఇంటిగ్రేషన్ నుంచి వచ్చింది. Alright, so I should get this answer when I integrate this. Alright, let's see, do we get this or not? So y is ఎంత? 2x by root 3. So element ఎంత ఉంది? 2x by root 3 into dx. This is my area. Sigma naught into area is my mass. I integrate this from 0 to, what is the limit of x? From 0 to ఎక్కడి నుంచి ఎక్కడ వేరే అవుతుంది ఇది?
Sir, from 0 to L naught.
0 to?
L
L naught,
naught.
sir.
L naught.
No, see, this is L naught. ఇది ఎంత ఉంది? Height of the perpendicular height of the triangle. L naught cos 30 కదా?
Yes, sir. Root 3 L naught by 2.
Right. So sigma naught into 0 to L naught root 3 by 2.
Sir,
Now let's
trigonometric
see.
functions use చేస్తారు.
Sorry?
Trigonometric functions use చేస్తారా?
L cos theta రాశాను. ఇది రైట్ యాంగిల్ ట్రయాంగిల్ కదా?
Okay, sir.
Okay, otherwise I can use Pythagoras theorem also. L naught is L naught by 2. L naught minus L naught square minus L naught by 2 square is this square. Pythagoras theorem రాయొచ్చు.
Yes, sir.
ఈ triangle. Right. Now this is my total mass. నేను ఇంటిగ్రేట్ చేస్తే ఇది రావాలి. Because sigma is constant here. So 2 sigma by root 3 comes out. Integral x dx. Integrating from L naught root 3 by 2. ఇప్పుడు ఎంత ఉంటుంది? 2 sigma naught by root 3 into x square by 2 under limit 0 to L naught root 3 by 2. So this 2 gets cancelled out. Sigma naught by root 3 into L naught root 3 by 2 whole square. So 1 root 3 gets cancelled out. I'll have sigma naught into root 3 L naught square by 4. I got the same thing as this one. If at all you forget any formula and you have time to integrate, you can integrate and get the formula. But if at all it's constant, we'll go with the formula. If sigma is not constant, we have to integrate. That time we cannot go ahead with the formula. Formula works only when it's constant. Mass is equal to sigma into area is only when sigma is constant. So here I'm getting out, turning out to be sigma into area, where mass is sigma into area. But how did I get to this answer? I've considered sigma into dA. So dm is equal to sigma naught into dA, where dA is a small element. When I integrate this, I'll get total mass m under the proper limits. All right.
Sir, can you repeat once again?
Yeah.
First steps.
Sure.
Starting nuncha.
First steps.
Okay. First
M
step.
is equal to.
Okay.
Sir, M
See,
is equal to, sir, first.
ఇది చెప్పాలా?
Yes, sir.
చూడండి, in any integration problem, all I do is I consider a small element, I write mass of that element and integrate that element, integrate the whole thing. Mass element రాయడానికి నేను ఏ ఫార్ములా యూస్ చేస్తాను? Mass is equal to dm, small dm, d ఎందుకు రాస్తున్నాను? స్మాల్ ఎలిమెంట్, ఇన్ఫినిటెసిమల్ ఎలిమెంట్, dm, డిఫరెన్షియల్ ఎలిమెంట్. dm is equal to sigma into dA, sigma of x into dA. ఇప్పుడు dA ఏంటి ఇక్కడ? లెంత్ ఆఫ్ ద స్ట్రిప్ ఇంటూ విడ్త్ ఆఫ్ ద స్ట్రిప్. లెంత్ ఆఫ్ ద స్ట్రిప్ ఎంత వచ్చింది? 2x/√3 ఇంటూ విడ్త్ ఆఫ్ ద స్ట్రిప్ dx ఉంది, ఇంటూ సిగ్మా ఆఫ్ x ఎంత ఉంది? కాన్స్టెంట్ సిగ్మా ఉంది. సో dm is equal to sigma naught into 2x into /√3 into dx. This is my elemental mass. ఇలాంటి అన్ని మాస్ సమ్అప్ చేస్తే నాకు టోటల్ మాస్ వచ్చేస్తుంది. దట్ ఈస్ నథింగ్ బట్ ఇంటిగ్రేటింగ్ ఇట్ ఫ్రమ్ 0 టు ప్రాపర్ లిమిట్స్. ఇప్పుడు నేను 0 నుంచి మొత్తం కవర్ చేయాలంటే, వర్టికల్ స్ట్రిప్స్ కవర్ కావాలంటే, వర్టికల్ స్ట్రిప్స్ ఆర్ గోయింగ్ ఫ్రమ్ 0 so on till when this vertical strip matches with this edge. This edge is at a distance of L0/√3 to L0/√3/2 కదా.
Yes.
So I integrate from 0 to L0/√3/2. I'll get total mass M. That's what I'm doing.
Yes, sir. I understood, sir. Thank you, sir.
Most well. ఓకే, ఇప్పుడు ఒక సర్క్యులర్ ప్లేట్ ఉంది.
సో మనకి ఇంతకు ముందు క్వశ్చన్స్ లో 2 కండిషన్స్ ఉన్నాయి కదా సార్?
సారీ,
ఐ మీన్ ఇంత ముందు క్వశ్చన్ లో ఇంకో కండిషన్ ఉంది కదా సార్, C0x.
oh C0x. Okay, you want me to do that also? Okay, you can do that as homework otherwise. Okay, I'll just write the equation, you do it as homework. So at a
Okay.
distance x, I consider a thin strip of width dx. So area of that strip ఎంత ఉంది? 2x/√3 into dx, because my mass is sigma of x into dA. Now sigma of x ఎంత ఉంది? ఇప్పుడు C0x ఉంది. I integrate this from 0 to again proper limits. What are the proper limits? L0√3/2. So 2C0/√3 outside x square dx from 0 to L0√3/2. What is integral x square?
Sir, x³/3.
Correct. Now substitute this, you'll get the answer. Right, that's the mass of the whole strip when x is sigma is varying as C0 into x, linearly varying. ఇక్కడ చాలా థిన్ ఉంది, less density, x increase అవుతూ ఇక్కడ density ఎక్కువ density. So this going on, density is going on changing from here to here. ఇక్కడ ఎక్కువ డెన్స్ ఉంది, ఇక్కడ తక్కువ డెన్స్ ఉంది. So look at this. I am considering a strip such that my area, mass on the strip is, sorry, density on the strip is constant. I am selecting such a strip. Always. I am not selecting at a distance x, E dx consider చేయట్లేదు నేను, or at a distance of tau, d tau consider చేయట్లేదు, because mass of this is not constant. Sorry, sigma on this is not constant. Sigma is constant over here. You will understand this next example. All right. I hope this is done. You
Sir,
solve this.
got the
Sorry,
answer.
you got the answer? What's the answer?
Sir, L naught raised to 4 by 4. Sir.
So C naught L cube by 4, sir.
C naught L cube by
4.
Sir,
right.
నేను అనుకున్నా సార్ సి నాట్ ని.
C naught A?
సార్ ఎల్ నాట్ అనుకున్నా సార్ సి నాట్ ని.
No, my handwriting. Okay, sorry for that. All right, that's okay. You got it. Now let's go to one interesting one. Say I've got a circle. Radius is R naught. My density is varying with respect to radius as, let's say, first case లో sigma naught constant ఉంది, ఇంకా second case లో some k into x ఉంది, or c into x. C naught రాస్తే మరి n అనుకుంటారా? C into x అని రాస్తాను. C naught into x. Okay, I'll take care of my handwriting. Now I'll consider a strip such that my density on the strip should be constant. I cannot consider a strip like this now. At a distance of x, my density, my strip is like this because my x is my radius here. So at a constant radius, ఒక స్ట్రిప్ తీసుకుంటే, సర్క్యులర్ స్ట్రిప్ తీసుకుంటే, now this strip, now mass of this strip is what I have to find out. Radius is x, sigma of x, width is dx. Now density on this is constant, right? Because at a distance x, it is varying with radius. X vary అయితే, సారీ ఇది x వేరీ అయితే సిగ్మా వేరీ అవుతుంది. సిగ్మా నాట్ తర్వాత చేద్దాము. x వేరీ అయితే సిగ్మా వేరీ అవుతుంది. బట్ నౌ I didn't select this part because it is not, my density is not constant along this line, along the strip. I have to select a strip so that my density is constant along the strip. Only then I can write dm and then integrate. How will I write dm? Because dm is constant density into area. So what is the constant density over there? Sigma of x into area. What is area? 2 pi x into dx. ఇది అర్థమైందా? 2 pi x dx ఎలా వచ్చింది? 2 pi x is the length, dx is the width. ఇది కట్ చేసి ఓపెన్ చేశాను అనుకోండి, ఇలా ఓపెన్ చేస్తే ఒక రెక్టాంగిల్ ఫామ్ అవుతుంది కదా, dx width, 2 pi x length.
Yes, sir.
So 2 pi x into dx is dA. Sigma into dA is by dm. I integrated from 0 to r naught. I get total mass. All right. Now
Yes,
look at this, students. Now look at this. I'll substitute sigma of x as c naught x. C naught x into 2 pi x dx, integrating it from 0 to r. 2 pi c naught comes out. Integral x dx is x cube by 3. Sorry, x square dx is x cube by 3.
by 3.
Under limit 0 to r naught, I'll have 2 pi c naught r naught cube by 3. All right, this is just mathematics. You understand till here. How to frame an element and frame an integral is very important. ఇది క్వశ్చన్ లో ఎలాంటి ఇస్తారంటే యువర్ ఇంటిగ్రేషన్ బికమ్ సింపుల్, అలాంటి వాల్యూస్ ఇస్తారు, ఆర్ అలాంటి వేరియేషన్ ఇస్తారు, సో దట్ యువర్ సింప్లిఫికేషన్ బికమ్స్ సింప్లర్. బట్ యూ హ్యావ్ టు అండర్స్టాండ్ హౌ టు ఫ్రేమ్ అన్ ఇంటిగ్రల్. దిస్ ఇస్ వెరీ ఇంపార్టెంట్. దిస్ పార్ట్ ఇస్ వెరీ ఇంపార్టెంట్. మీరు ఇంటిగ్రల్ ఎలా ఫ్రేమ్ చేస్తారు, ఈ ఎలిమెంట్ ఎలా ఫ్రేమ్ చేస్తారు, ఎలిమెంట్ ఎలా తీసుకుంటారు. ఫర్ ఎగ్జాంపుల్ వీ హావ్ గాట్ 7-8 minutes మోర్. ఫర్ ఎగ్జాంపుల్, సిగ్మా నాట్ కాన్స్టెంట్ ఉంది అనుకుందాం. Alright, so sigma is not varying, but it's constant. Sigma of x is constant throughout. That time, I can take any kind of element. I can take this element, I can take circular element, I can take arc like this. There are many different ways of doing it. But depending on the question, again, we'll take an element. But let us take two cases where I'll take this element and also circular element. ముందు circular element తీసుకుందాము. What am I supposed to get the answer as? Density into area. Sigma naught into pi r square should be my answer. Sigma naught into pi r square should be my answer. Right? Because constant undi kada. Whenever it's constant, I can multiply that with the area, I'll get the total mass. Now I should get this with the integration also. Whether I take this strip or this strip. A strip తీసుకున్నా, I should get the same answer. But I will consider as convenient strip. ఇప్పుడు ఈ స్ట్రిప్ తీసుకొని రాస్తాము ఎలిమెంట్. What is dA here? 2 pi x dx. ఇది x అనుకుంటే dx is the width, 2 pi x dx is the area, sigma naught is area into sigma naught is dm. I integrate this from 0 to r naught. I get total area, total mass. So 2 pi sigma naught x dx anta x square by 2 under limit 0 to r naught. So I'll get pi r naught square into sigma naught. And that's what I got.
So,
But now, look at this. I can take any strip I said. Because it's constant, I can take any kind of strip. Previous case law, it was varying radially, so I could take only circular strip. I could not take this strip. అలా కూడా చేయొచ్చు. In engineering level you do it, or graduation level you do it. But at intermediate level, you take only one strip where you write a one integral only. Single integral. Double integral, triple integral కూడా రాయొచ్చు. Alright, that is also possible. I'm not saying it is not possible. It is possible. But the only thing is at plus 2 level is enough. At advanced level, that's sometimes required. Double integral is sometimes required. All right. Now let us, instead of taking the circular strip, let us take this strip. Now, what is the area of the strip? Width is dx, and a distance x, radius r naught. What is the length of this one? Pythagoras theorem. Pythagoras theorem చెప్పండి. Tell me what is the length of that?
root r naught square minus 8 square.
Correct. Into 2, because కింద కూడా ఉంది. Total length is 2 into r root of r naught square minus x square into dx into sigma naught. మొత్తం కవర్ కావాలంటే ఐ వాంట్ ద హోల్ డిస్క్. అయితే x ఇక్కడ ఇది ఆరిజిన్ అనుకుంటే దిస్ ఇస్ మైనస్ r naught, దిస్ ఇస్ ప్లస్ r naught. సో మై x is going from minus r naught to plus r naught. Minus r naught to plus r naught. Now this దీన్ని ఇంటిగ్రేట్ చేస్తే కూడా what we get is sigma naught into pi r square. But here integral is difficult. Root of r naught square is x square. అది ఇంటిగ్రేషన్ యూజ్ చేయాల్సి వస్తుంది. That your calculus math you have to use. Alright, formulas ఉన్నాయి. But this is little bit difficult. So choosing an integral element, is very smartly choose an element such that your integration becomes simple. And the variation is given such that your integration becomes simple, but framing of the element is wise. You have to be wise in framing the element, framing the integral. All right, integral framing is very important in the problem cracking. Problem crack చేయాలంటే integral frame సరిగ్గా చేస్తే remaining becomes very simple. ఇప్పుడు let us say if I were to give you some variation. All right, that we'll talk about later. Next class లో మాట్లాడతాము. Next again, whenever we have only IT class, we'll talk about it. Remind me, we'll continue this there. ఇప్పుడు సిగ్మా చేస్తున్నాం, అలా రో కూడా చేద్దాము. Alright, we'll cover everything, all the integrals at once. But practice is very important. నేను ఏం చేస్తున్నాను, once you just practice it. At a distance x, consider a thin strip of width dx. Tell yourself, and that area of that element is dA. Sigma into dA is my dm. Integrating this dm is my total mass, but integrated from valid limits. What are the valid limits here? Minus r naught to r naught. And what is the area of the element? Length into width. Width is dx. Length into వచ్చింది Pythagoras theorem. Alright, do this once again.
so
Yes, Vignesh.
ఇలాంటి టైప్ క్వశ్చన్స్ ఇలాంటి టైప్ క్వశ్చన్స్ ఆ సింగేజ్ బుక్ లో ఏమైనా క్వశ్చన్స్ ఉన్నాయా?
ఆ చాప్టర్ వస్తుంది, లైక్ బేసిక్ మ్యాథ్స్ లో లేవు, బట్ బేసిక్ మ్యాథ్స్ లో వి హావ్ డన్ ఇన్ వీడియోస్ లో ఉంటాయి. బట్ వెన్ వీ కమ్ టు సెంటర్ ఆఫ్ మాస్ అలాంటి క్వశ్చన్స్ ఉంటాయి. Alright, work by energy center of mass లో ఉంటాయి. I'll show you the questions. If they are not there, I'll send some questions to you.
Sure, thank you.
Okay. Usually this is advanced level. All right. So we'll stop here. Join the next session. We'll continue with syllabus, circular motion. All right. ఏదైనా డౌట్స్ ఉంటే ఆపి అడగండి నాకు. All right. Don't let me just go ahead. Stop me and ask. All right. See you again, everyone, in 2 minutes.
Yes, sir. Students, you can join the next session. Join 7:30 to 8:30 link.